types of t-test. We're going to use all three at the same time. So there is logic to my madness. So right now we have to spread out and use all of Lucas's whiteboard in his beautiful imagination room, because looking at the three tests together, actually in my sense and my experience of being a professor for so many years, it's actually easier for people to see them all and they all click in your brain than understanding one and then trying to figure out the second and then trying to figure out the third independently. But once it clicks, hopefully it all clicks together, and now you've learned three t-tests. So starting with the first, we have the one sample t-test, right? Then we have the second. We have the independent t-test. Then we have the dependent t-test. So let's talk about their alternative names. The one sample t-test we talked about being an approximate z-test. Z like in zebra. It's also known as the approximate z-test. The independent t-test is known as the two samples t-test. It is also known as the between subject designs t-test. We'll talk about why it's called between subject, right? So the between subject t-test. And the dependent t-test is actually known as the paired, which you'll actually see in SPSS. And it's also known as the repeated measures. And it actually has a third name. It's also known as the within subject t-test. So why all of these names? Let me show you the formulas, then we talk about them, and then hopefully it'll start to make sense why all these names are used. So the one sample t-test, remember, all three of the t-tests are essentially doing what? They're looking at an approximate z-test. They have less information, right, of the population. What we're talking about in terms of less information, we specifically do not have. So it's an unknown standard deviation. In other words, we do not know the population standard deviation. This is unknown. And what are we working off? We're working off of estimates. That is the key difference between the t-test and the zebra z-test. But we're still looking at normal distributions to be able to run these tests. So if we're looking at the one sample z-test, how many samples do you think you have? One, hence the name, the one sample z-test. So n, one sample. In the independent or two samples t-test, how many do we have? N, two samples. In other words, we have the first one and the second one, right? And if we're talking about the dependent t-test, we only have one sample, but each sample or each person within the sample group is asked the question twice. So in reality, here we look at something called difference scores. So every person has two X's. We have X1 and X2. Every person will be asked a question twice within the same specific group. So let's look at the formulas. If we're going to run an actual one sample t-test, then we do the t equals, just like the z-test, we have the mean minus the mu. The difference is, instead of having the Greek symbols, we go to regular symbols. So we have SM as opposed to sigma m, right? We got rid of the sigma. So in reality, what we're looking at is the estimated standard error. But just like before in the z-test, it stands for a formula. But once again, we got rid of the Greeks. So we're doing s over square root of n, or we're doing s squared over n and square root the whole thing. And if you don't remember what these are, remember, S stands for standard deviation, the sample, N stands for the sample size, S squared stands for the variance, and once again, N is the sample size. Why can we put the whole thing under a square root? Because remember, to get the standard deviation, we square root the variance. So we can actually square root the whole entire formula and do variance divided by N, or standard deviation divided by square root of N, and still get the estimated standard error. This becomes important because it makes a little more sense to use this formula than to use this formula as we move forward within the other tests. So independent t-test. If we have a formula where it's singular, and we're going to now think about the independent t-test being two samples, the easiest thing to do is double the formula. So we have t equals, we have how many m's? In other words, how many samples? 2. So we have the mean of the first sample minus the mean of the second sample, parentheses, and we're looking at a sample mean difference, the difference between the samples. So we're looking at the difference between the samples, we also look at the difference between the populations. So mu1 minus mu2, just like we did here. We have 2 mu's and 2 m's. And just like we did over here, we're going to have a double bottom. So you can square root the whole thing, and then you'll have 2 variances and 2 samples. So you'll have the variance of the first and the sample size of the first combined, because here we're combining them all. All of the estimated standard deviations are being combined to test against the sample mean difference. So then we combine them and we'll have the variance of the second divided by the group of the second, the sample size of the second. So combining all this is going to now test the difference amongst these samples themselves, which essentially is the difference amongst their populations, because samples will always reflect against populations. So if you look at the formula, literally it's the same one, just doubled. Why? Because we have 2 samples. Why is it called between subject? Because we're testing between 2 subjects. We're looking at, let's say, males and females. So the difference between the male group versus the female group, hence between subject. That's why their names come like that. And if we're doing the last one, then we look at it saying this is a 1 sample test, but we're looking at differences. So it's going to almost look like the first one in the idea that we will have an m minus a mu, an estimated standard error. But why is it different? Because we're looking at a person asking them twice. So remember I told you here difference scores? We actually have to look at the mean difference, and the mu difference. So the difference amongst the sample, the difference within the population, and the estimated mean difference. So in other words, here, we're going to ask everyone, what is your pre and post score? And then subtract your post minus your pre, and do the same process of the actual mean. Ask everyone your x2 minus your x1, x2 minus x1, get a brand new set of values, add up those values, divide by how many people are in your sample group, and actually get an actual difference score. Not an average score, a difference score. And that difference score is the one that we're going to use here in terms of measuring that mean difference once we complete the process. So think about it. Here on the bottom, if it's an estimated mean difference and it's only 1 sample group, then guess what the bottom of the formula looks like? Just like the first one. So it's actually s squared over n square root, or you can do the s divided by the square root of n. In other words, standard deviation divided by the sample size. So if you start to look at all 3 of these formulas, right? Here we're looking at 1 sample, 1 population, 1 standard deviation, 1 sample size. But then when we move on the 1 sample t-test, we're looking at the independent t-test. It's telling us we're looking at 2 sample groups. The limitation of the actual t-test, the t-test can only measure 2. The difference amongst 2 groups, the difference between 1 group and its pre and post choice, or its choice of 2 things. Do you like black versus white? Do you prefer something bought by you or bought by others? What do you think in terms of McDonald's French fries versus homemade French fries? So you see, one person is being asked 1 question. Hence why this one's called the repeated measures. You're repeating a test with the same group within subjects, the same group within the subject is being asked the question, or you're paired against yourself. So you see, these 3 tests all do the same thing. They talk about introducing something new onto the population using a normal distribution, But the t-test requires less information of the population, like when a new product is introduced onto the market. And you can test the difference amongst male and females choices, the difference amongst one group and two choices within one group, or just a snapshot of one sample and their opinion. But they're all essentially the t-test.